Okay, we're going to begin our discussion of analytic geometry by talking about some of the various conic sections. So what are we talking about? Well, if you have a cone, and in this case we have two cones, one stacked on top of another, point to point or tip to tip, and you intersect a plane with that cone, you actually get what we call these conic sections, and you've probably seen them before. One of them, or maybe two of them, may be more famous than the other. But if you look at this first one right here, this one is pretty famous, a parabola. You've been talking about parabolas forever, probably, but you didn't quite know that it was actually a slice of a section of a cone. And so this is what we mean by conic sections. So we're going to first talk about parabolas, but then we'll eventually talk about ellipses and hyperbolas. Okay, so we'll talk about those, in another video, but today we're going to talk about parabolas. So let's go ahead and dive in and talk about parabolas. And you've probably seen them before, you probably worked with them before, but we're going to take a look at them from a really different perspective. So let's go ahead and see what we're going to talk about. So parabolas, in this case with a horizontal axis, is our focus today. All right. We're going to look at a parabola. If it's got a horizontal axis, that means that it's facing sideways. Okay, it's not typical of the vertical, up and down parabola maybe that you're used to. All right, this parabola is going to be facing sideways, but to graph it is no different than what you've done before. All right, so that's kind of what makes it neat and makes it, quite simple, because you've been doing this before. All right, so this parabola will open to the left or to the right. It all depends on the number here. All right, if it's right, it would open. If it opens to the right, rather, it would be a positive a value, a positive coefficient in front of your y square. And if it's facing to the left, it would have a negative value for a. Okay, so we're going to take a look at our first example, and we're going to graph that, and then we'll take a look at a couple others, and you'll see that it's actually quite intuitive and really similar to what you've already been doing. So we look at this first one, x equal y squared minus 4. Well, I'm going to stop and I'm going to say, okay, well, I remember graphing x squared minus 4. All right, this, if I factored it very quickly, is a difference of two squares, and it has roots at positive 2 and negative 2. So x equal negative 2, x equal positive 2, right? So this one is no different. So where we used to have a graph that looks something like this, okay, looks something like that. Well, the graph's going to look something like that. The difference is that because it is y squared and that coefficient is just a 1, all right, that means it's going to open to the right. Okay, so it's no different than what we've been doing before, except we're going to rotate it. So let me go ahead and erase this, and we're going to turn this graph on its side. Okay, so let's see here. It is a parabola with roots at 2 and negative 2 right here, and it's shifted downward 4 units, 1, 2, 3, 4 right there. And that we said it would open to the right, and sure enough, it's opening to the right. So that is what this first graph looks like. Nothing really to it, okay? So let's go ahead and take a look at another example. In this example right here, we are asked to graph a slightly different parabola, not as simple as the last one, but that's okay. Because we remember something about finding the vertex, perhaps. And if you can find the vertex, and the rest of it is really simple. And we're just going to kind of do our best sketch. So the whole focus here really is the concept. And the concept that I need you to understand is how to find the vertex, really. So if you recall, when we graphed a regular parabola, we said, well, the vertex is equal to opposite b over 2a. And the that's the x-coordinate of the vertex anyway. And if we do f of the opposite b over 2a, that is the y-coordinate. So what happens, because our parabola is turned on its side, we actually have the opposite case. Okay, it looks something like that. All right, so it's just reversed, but it's not a terribly big deal, and we're going to do it. So let's first figure out what a, b, and c are. A is 1, b is 4, and c -3. Okay, so let's see. Opposite b, that would be -4 over 2a, which is 2 times 1. So this is our y-coordinate of the vertex. That's going to be -2. All right, so it's really quite simple. Now to find the x-coordinate of the vertex, I'm going to say, okay, f of -2. So I'm going to plug in -2 for y, and I'm going to get my x-coordinate. So this becomes 4 minus 8 minus 3. 4 minus 8, -4, minus 3, -7. So x equal -7. And so my vertex, and I'm going to write that down, is -7 and -2. So let's see here. 1, 2, 3, 4, 5, 6, 7, -7, and down 2, somewhere in this ballpark here. Okay. Now, I'm not going to be entirely accurate when it comes to my sketch, so I'm just going to use my best estimate. I mean, if you really wanted to, if the parabola here is factorable, then you can definitely do that. You can factor and try to find the roots. Okay, so when I graph this, you know, it's going to be, oh, I'm trying to get a ballpark here. Let's see here. Give me 1 second. Okay, so something, you know, maybe about right there and right there. That seems about right. Okay, this one actually not factorable at all. It's said to be prime, but if you were to kind of do a quadratic formula, you'd get the roots there. So maybe it doesn't look quite parabolic, but you get the picture. A parabola that would be opening up sideways like that. All right, so it's a rough estimate of what it would look like. Probably a little bit difficult to graph this on the calculator given the way that it is, but if you graphed it upright, if you said y equal x squared plus 4x minus 3, you'd easily find those roots. And that's not a big deal, but just turning it on the side. Okay, so really, really nice example there. But let's go ahead and take a look at one more example. And this next one will actually be a lot easier to work with because it's in vertex form. So let's go ahead and take a look real quick at the vertex form formula. All right, here is the vertex form one more time. All right, so this is our H and our K, and that's going to help us with our, so usually we'll say plus H over here. So that's going to help us with our vertex. So it's not a big deal, but let's take a look at the example here because it's already in vertex form. So let's consider what the vertex is, HK. All right. So the H is going to be, it looks like a positive 7 and a negative 4. 7, negative 4. H and K, because this is of course H and this is of course K, but remember it's always opposite of whatever is inside of the parenthesis. So 4, let's say 7 is somewhere in here and negative 4 is right about there, so our vertex somewhere there, and then the parabola is just opening up sideways this way. So that's my best guess of what it might look like. Maybe, maybe not. But I know that it's facing to the right because of the fact that the coefficient here is a positive 1. So it has to open to the right. Okay, so three really nice graphs of parabolas and how we might graph them by hand. So a good conceptual understanding here. So remember, if this video was helpful, if you liked it, be sure to like and subscribe.